Hello, greetings, and welcome. So this week we are wrapping up Chapter 2 on linear programming, and the chapter ends with the discussion of postoptimality analysis. And so in this example problem, we are going to revisit example 1 from week 3, where we're trying to create a feed mix blend using corn and soybean meal. And in terms of postoptimality analysis, we're going to ask some what-if questions. And I won't be solving anything by hand, but instead I'll use our spreadsheet, so our Excel sheet, or in my case LibreOffice Calc spreadsheet, to essentially change variables, adjust constraints, and then resolve and look at what the effect is on our solution. Okay. So what we're starting with is the problem statement, and then again solution can be found in our week 3 solution. And what I'll start with is the spreadsheet that we had created there. Again, if you wanted to look at the solution, it's there, but I'll mostly play around with the Excel sheet and answer the what-if questions that follow in this question section. Okay. All right. So if you were to revisit the other problem, so there's information about our corn and soybean, and we were given, how much protein and fiber is in corn and soybean, the cost per pound of each. We are told that we need to make at least 800 pounds of the feed daily, that at least it must be 30% protein and 5% fiber. And so if we were to look at the spreadsheet we had set up there before, so here's essentially our copy of the table. Our variables were the amount of corn and soybean used to create this final mix. Okay, so our objective function was the total cost, which we're trying to minimize. Okay, our constraints are that we have to make at least 800 pounds. Okay, at least 30%, so at least 30% is protein, and then at most 5% is fiber. Okay, and so just to make sure we have our spreadsheet working, okay, so our goal is to minimize the cost by changing the amount of corn and soybean used. In terms of constraints, we had to make at least 800 pounds. Okay. We had to have at least 5% protein. And then our fiber constraint was at most 5% fiber. So keep result. And then the other thing I'm going to do is let me make sure I have my non-negativity box checked. Okay, so we have the same answer as before, which is what we expect. Okay, but just want to make sure we have it working, and that solver is working and functioning, because it'll make it all that much easier as we tweak and play with these what-if questions. All right, so in our solution right now, okay, in which all our constraints are satisfied, our cost was $437.64 per day to make 800 pounds of this food. Right, our 800 pound constraint was solved exactly. In terms of protein content, that must be at least 30% protein, so that's satisfied exactly. In terms of fiber, it could be at most 5% fiber. We are, below that threshold. We have less than 5% fiber in our meal. Okay, and our meal is predominantly corn, and it makes sense looking at the contents of the feed stuff. So the corn is cheaper per pound, and it also has less fiber and less protein. Okay, where soybean has a higher protein and a higher fiber content. So, all right. So now, if we play with our questions, our what-if questions. So, question 1: you'd like to support the local soybean farmers in your community. You would therefore like to increase the fraction of your final feed mix that is soybean meal. By how much would the cost, dollars per pound, of soybean meal need to decrease for the optimal solution to contain at least 400 pounds of soybean meal? So the question is okay, currently I could buy soybean meal for 90 cents per pound. Okay, what would that price need to go down to in order for me to use at least 400 pounds of soybean meal? And then I could go and say communicate with my local farmers of, hey, discount my soybean meal by this much, and I will buy this much more from you. So if I go to my spreadsheet, okay, and I'm going to copy it, okay, and I'll call this, say, part 1. Okay, so essentially what we want to do is we want to tweak the cost in terms of dollars per pound of our soybean meal, and as the cost decreases, and so then if I look at my objective function, right, the cost decreases, so that's D4, the coefficient D4 is going to decrease. We want to look at, as that decreases, how does that affect the optimal amount of soybean used, and we'd like to see if we can get that up to 400 pounds. Okay, and so if I were to change that to, say, 80 cents per pound, okay, and then the nice thing with Solver is everything saved from when I just solved on the original spreadsheet, and my spreadsheet's not changing at all except for the value of that parameter. So I can just click Resolve, keep result. So as it goes down to 80 cents, the amount of soybean actually hasn't changed, right? That value's exactly the same. So my cost has decreased, but the amount of soy hasn't. Okay, let's go a little more drastic. So if I change that to 50 cents per pound and solve, okay, the amount of soy used still hasn't changed. If I change it to 30 cents per pound, so it's the same as corn, okay, now it's 600 and 200 pounds, so now it definitely has made a difference. If I increase it from there to 40 cents and solve, I'm back at, so I started with 90 cents, right? When I was 90 cents per pound, the optimal amount of soy to use is 329.4 pounds, right? Even as I decrease that to 40 cents per pound, the amount of soy hasn't changed. So it's not until I changed the price of soy to be the same as corn that I actually get a change. 35 cents per pound, it's still the same. Okay, 31 cents per pound, still the same. Okay, so I'm only going to get a change in the optimal amount of soy used when the cost of soy is exactly the same as the cost of corn. Okay, so going back up to the question at hand then, okay, so the current cost of soy is 90 cents per pound. If I decrease that cost, I'd have to decrease that cost all the way down to 30 cents to be the same cost as the price of corn in order for me to use more soy. On the flip side of things, you could also look at what would happen if the cost of soy increased. Okay, so we started at 90 cents per pound. I'm going to just resolve to bring us back to that base. All right, we're at our 329 pounds used. Okay, what if I change this to, say, $1.20? So as I increase the cost up to $1.20, the amount used hasn't changed. If I make it $1.50, the amount used hasn't changed, but my cost has gone up. So as long as the cost of soybean meal is greater than the cost of corn, then the amount of soy that I'm going to use won't change. So on the flip side of things, it could be that the local soybean farmers could begin to charge more for their soy meal, and my optimal mix still wouldn't change. My cost would increase, but that optimal mix wouldn't change. Okay, so that's cool. So as long as my soybean the cost is greater than 30 cents, in this case keeping corn fixed, then it seems like I can just keep increasing the cost of soybean, and the amount of soybean used won't change. Cool. All right, question 2 then. So now we're going to start with the same original problem. We're told our veterinarian has suggested that the feed be at least 7% fiber. So in the original problem, it's written as at most 5% fiber. So now we're told that we want our feed to be at least 7% fiber. What is the new optimal composition of the feed mix? Okay, so I'm going to copy our original solution. Okay, and I'll call this, say, part 3 or part 2. All right, so in our current scenario, a requirement is that we have at least or at most 5% fiber. Okay, at most 5% fiber. So when I look at our original solution, the amount of fiber that we actually have is less than 40, which is less than that case of, if our final feed mix was 5% fiber. Okay, so we're currently, underneath that maximum threshold of 5%. So now we want to increase the amount of fiber to be greater than, or at least 7%. So it's going to be greater than or equal to 7%. So we're going to need to increase the amount of fiber. Okay, so we can only imagine the cost is going to increase, but let's see what happens. So if I go to fiber, then so if I keep this the same, basically what's going to happen is this last constraint is my fiber constraint. So it's no longer that the amount of fiber is less than or equal to that 5%. It needs to be greater than or equal to. So when I adjust it as that and keep this at 5%, then it's tops out at the exact amount. Okay, but what I need to change this to is 7%. Okay, so now if I solve, okay, 7% tells us no solution. Okay, so 7% tells us no solution was found. The model is at infeasible check limiting conditions. So what ends up happening is when I set that limit to be 7% has to be fiber, then it's not working. Okay, it tells us there's no feasible solution. So let's check our constraints one more time. So that's our total feed stuff. It's going to be greater than or equal to 800 pounds. There's our protein content needs to be greater than 30%. And now we're saying our fiber content needs to be greater than 7%. So all of these should be right. They should all be greater than or equal to signs. And when I do that, we find that there's no solution found. Okay, and so that's interesting. And then one thing is, again, if I change this back instead of 7%, but said I needed at least 5% fiber. Okay, well, it looks like the solution is already satisfied. But if I solve under that condition, I find that if I use 200 pounds of corn and 600 pounds of soybean, right, then I get my 800 pounds of feed stuff, and I exactly satisfy that fiber constraint. Okay, but this is suggesting is, so say I were to go up to 700 pounds of corn, it should work because this is greater than or equal to, or it would seem like it should work, but let's see, because I want to minimize my cost. Yeah, the issue is we want to minimize our cost. And so we're requiring our total amount of feedstuff is greater than 800. Our protein content's greater than that 30%. Yeah, so we can solve with 5%, but it's not the case if we were to change this to 7%. Okay, so this value would need to increase. And we get this no feasible solution. Okay, so yeah, cool. Okay, and just to check, all right, so we have linear solver and non-negative values. Excellent. Okay, so 7% no feasible solution. So even if I were to, crank this up, so I have 700 pounds of corn or soybean, right, I'm still not going to get over that, right? I can make this. So if I were to make this, I don't know, 1,000 pounds of soybean, right, I'm still not getting over that fiber content. Okay, and I think the issue is if I look at this, this is per pound. So I have 0.06 pounds of fiber per pound of feed stuff. So even if I had this as pure soybean, the greatest I can get up to is 6% of my feed mix will be fiber. Okay, so it's just not feasible. Okay, so in terms of coming back to this, based on just using corn and soybean, it's not possible to get up to 6% or 7% fiber. The highest we could get is 6%, which would be pure soybean. Okay, so you can't get up above 6% pure fiber. So if you wanted to get up to 7% or above 7%, we would need to add some new feed materials. Okay, cool. So no feasible solution, and doing a sanity check. Soybeans only 6% fiber, corn's only 2%, so there's no way to get up above 7. Okay, so I'm going to copy our original again, and we're going to look at part 3. And before I get to part 3, I'm just going to make sure this is working right. And so when I do that, okay, that's 5%. And this is going to be a less than or equal to sign again, since we wanted at least or at most 5% fiber. All right, so now if we look at 3, it says you've been put in touch with a new corn supplier who could provide corn at a cost of $0.2 per pound. Will this change the feed composition? So now we're going to decrease the cost of corn from 30 cents per pound to 20 cents per pound. And what will happen? And let's see, if we just look at this, we know that we need at least 30% of our mixture is going to be protein, right? And so that's where you need a blend of soybean and corn, because our corn's only 9% protein, and soybean is 60%. So you need a blend of the two. The question is, are you going to be able to use more corn? Are you going to use more corn once the cost decreases? If you think about problem 1, when we looked at it, as long as the cost of soybean was greater than the cost of corn, then we found that our mix didn't change. Okay, so I guess just based on that, let's see what happens. So if I were to change corn to 20 cents, our cost decreases. Okay, but our mixture doesn't change. So this is if I were to take this all the way down to 10 cents, would anything change? And the answer is no. And our cost goes down, but the mix doesn't. What we had found though before was as long as our soybean cost was greater than 30 cents, that original cost of corn, then the optimal mix didn't change. So then the question is, could I change, say, the corn up to 80 cents per pound, where so long as soybean costs more than corn, the mix doesn't change? And if we do that, all right, we find we get the same thing, right? So back to part 1, as long as the cost of soybean was greater than the cost of corn, the optimal mix didn't change. So, decreasing corn down to 20 cents doesn't change the mix. All it does is decrease my cost. Okay, so yes, give me that new supplier, it'll decrease my cost, but it doesn't change the optimal mix at all. So on the flip side of things too, that corn supplier could charge up to 89 cents a pound, and it wouldn't change things at all. All right, fun times.